Hi, and welcome to Dr. V's Chemistry Webcast. Today we're going to be talking about properties of matter. I wrote this webcast to be suitable for first-year chemistry students who need an introduction to this topic. You can see I wrote it for my honors chemistry students, and so that's really what it's geared towards. So let's go on and talk about the objectives for this webcast. I want to start by introducing physical properties and give some examples of them. And then I want to go on and compare intensive with extensive physical properties. After that, we'll talk about some examples of physical changes. Then we're going to go on and talk about chemical properties and some examples of chemical changes, otherwise known as chemical reactions. And then we'll wrap up with doing some practice problems. So let's jump right in. A physical property is a characteristic of a sample of matter that you can measure or observe. And when you measure or observe this property, you don't change the composition or the identity of the sample. You have the same material and the same chemical formula before you observe the physical property as you have after you observe the physical property. So some examples of physical properties include color, solubility, does the sample dissolve in a particular solvent, odor, hardness, mass, volume. There's lots of different physical properties. Refractive index, so if you wear glasses, the material your lenses are made of, how much does it bend the light? This is by no means an exhaustive list of physical properties. There are a lot of them. Another physical property is state of matter, and of course we experience these all the time, and you probably have a lot of prior knowledge with this. So we might be talking about solids. So if we have a solid, we're talking about a sample where the volume and the shape are fixed, right? And on a particle level, we're talking about particles that are usually very, very closely packed in a solid. We could be talking about liquids. So in a liquid, the shape of the liquid is determined by the shape of the container, but the volume is fixed. And the particles are generally pretty close together, maybe a little bit farther apart than in a solid. That's typical. But they're free to move around, whereas in a solid, of course, it's much more rigid. And we could have gases where the particles are much farther apart and I don't have a fixed volume or a fixed shape. So this is also, a physical property that we can observe for the sample. Now, less commonly, we might talk about plasmas. It's the least common state of matter on Earth, but the most common state of matter in the universe, because our stars are made out of plasmas. Your plasma TVs, they create a plasma when the current's on. But in chemistry, we tend to focus in a first-year course on solids, liquids, gases. There are also Bose-Einstein condensates, which are really cool, but really beyond the scope of anything we're going to do in chemistry this year. So, all right, extensive properties are something we can talk about in terms of physical properties. Extensive properties are properties of matter that depend on the amount of material in the sample, right? So if we think about that word extensive, extent, how much? If it depends on how much, it's an extensive property. So examples of extensive properties, all right, include mass, volume, the amount of heat involved can be considered an extensive property. All right, so they depend on how much material. The more material you have, the bigger the mass, the bigger the volume, and so on. All right, so those are extensive properties. Intensive properties are physical properties of matter that do not depend on the amount of material. They really depend on the nature of the material itself, which makes them very useful for identifying substances. All right, so examples of intensive properties, melting point. All right, if you've got a pure sample of water, all right, ice, it's going to melt at 0 degrees Celsius. The boiling point, our pure sample of water at 1 atmosphere of pressure, is going to boil at 100 degrees Celsius. Density is also an intensive property, right? So it doesn't matter if you have a big sample of iron or a small sample of iron, the density of a pure sample of iron is the same. So these are considered intensive properties. I'm going to tell you, if you only know one intensive property, make it density. Now, a physical change can be observed for a sample without having any effect on the composition of the sample. So before and after, you have the same stuff. So your phase changes are really common examples of physical changes. So melting ice, I have H2O beforehand in the solid form. I have H2O after in the liquid form, but it's still H2O. All right, I haven't changed what it's made out of. I haven't changed the identity of the particles, all right? Or just snapping something in two, ripping a sheet of paper. I still have the same materials. I haven't changed the identity of anything in the sample, right? So that's considered a physical change, right? And these are very common. So your phase changes are physical changes, ripping things, tearing things, putting things together. It's a physical change. Now, chemical properties, of course, are something we're very interested in a chemistry class, all right? A chemical property tells us how a substance behaves in the presence of other materials, all right? And when we observe a chemical change, we see a change in composition. We're actually going to make something new when we observe the chemical property. So, for example, if you light a match, right? Your common matches have phosphorus on the striking surface, all right? Phosphorus actually exists, these 4 atom molecules, and by putting it on the match strip, you actually change it from one form of phosphorus to another. And then the match head has potassium chloride on it, which is very, very reactive. You put these guys together, whoo, you get this flame, right? All right. There's a chemical reaction that's occurring. So I have my phosphorus and the potassium chlorate, all right? Those are my reactants, all right? They're my starting materials. We call them reactants. Afterwards, we have something totally different. We don't have P4 and KClO3. We have KCl and P2O5, and then energy is released as well. So my products have different chemical formulas than the reactants, and that's how we know it's a chemical change. I've got different identities, different formulas. Now, I'm not expecting you at this point to know what the products would be here. I'm also not worrying about conservation of mass in this description of the chemical reaction. I just really wanted to focus on the fact that my reactants have one set of formulas, and my products have different formulas. And then energy is released in this chemical reaction. We often see that with chemical changes, that there are temperature changes. So let's do some practice problems. Do these diagrams indicate a physical or chemical change? What do you think? All right, well, I'm looking at what's on the left. My reactants have are molecules with one purple atom and one yellow atom. And then after, I have molecules with purple atoms and yellow atoms still in molecules, but they're spread out more. To me, that's a physical change because I underwent maybe a phase change. I pulled them apart. But I don't have any change in the identity. The molecules still have one purple atom and one yellow atom. Okay, let's look at this one. All right. Beforehand, I've got those purple and yellow molecules. And then afterwards, I see yellow molecules, diatomic molecules, and purple atoms. To me, that's a chemical change. I've got different formulas beforehand. I might write AB for before, and then afterwards, I have A and B2. So this is, to me, a chemical change. Which of the diagrams here represents a pure substance? All right, so we're going to switch gears and do some classification of matter because that's what I feel like doing. So you have to go look at each picture individually for a pure substance. Remember, we're looking for only one type of particle. What are your best choices? Pause the webcast and think about this for a second. Okay, and then go on. So B and D are both pure substances. B is an element, D is a compound, but they're both pure substances. Let's do another. Which of the diagrams represents a mixture of two elements? Again, pause this, think about it for a second. What's your answer? And I want 2 elements. So the best answer is E. That's the only one, right? Everything else is, well, B is an element, but it's only one element. And everything else, and D is a pure substance, it's a compound. So A and C and E are all mixtures, but only E contains 2 elements. Which of the diagrams, represents a mixture of 2 compounds? All right. We know it's not B, and we know it's not D because those are pure substances, but we need 2 compounds, okay? So you can look at A, and you can look at C, and you can look at E. The best answer is C, all right? I've got 2 different kinds of compounds in there, 2 different kinds of molecules in that mixture. Which of the diagrams represents a mixture of an element and a compound? So again, I need a mixture, so I can eliminate B and D. I need an element and a compound. So I'm looking at A or C or E for mixtures, and I think the best answer is A, right? I've got the blue ones are an element, and then I've got the purple and yellow ones, and those are a compound, so A is the best answer. All right, and let's wrap this up, all right? Physical properties, we can observe without changing the composition. Chemical properties, we get new materials, new formulas. I think this is a really good ending point, so we'll stop here. Have a good day.